Yet one more way to solve systems of equations. Today's way is going to be called Cramer's rule. But to use Cramer's rule, you have to be able to find determinants to help determine what our solutions are going to be. So, 2 by 2 determinants are very simple. AD minus BC, end of story. The whole next slide is just finding 2 by 2 determinants. We've actually already done the very hardest one. AD minus BC. I'll do one more just for the heck of it. How about number 3? Number 3. What? No, that's the inverse. All I want today is the determinant. Hey. Oh, it was you I loaned a pencil to. Thank you. Oh, never mind. AD minus BC. Negative 24 minus 5 is negative 29. That would be the determinant of that one. If you get a determinant of 0, then your equation's not going to have a solution that you can find. Now, it could be infinite solutions. It could be no solutions. So don't really write infinite or none. Just write the indeterminable or something like that. Let's see. 5 is going to be like that. Somebody raise your hand and tell me, how do you think I know that I can just look at 5 and say, hey, that one's not going to have a solution we can find? Yeah. Or, I mean, look, the ratio is the same. The x's have a ratio of negative 7 halves. The y's have a ratio of negative 7 halves. They're going to have the same slope, which means either they're going to be parallel or coinciding, which means either no solution or infinitely many solutions. So that's what's going to generate you a 0 determinant. Cramer's rule says that to solve these systems of equations using the determinants, here's what you're going to need to do. First step, let me take one of these elsewhere. Let's do number, well, actually, let's play a little game. Let's see if we can just identify right off the bat which of these are going to render you, on the left-hand side, which one of those is going to render you a solution that you can't find? How do you know? Exactly. 1, 2, 1, 2, or whichever way you look at it. You're right. 17 is going to render you a 0 determinant. You can tell just by looking at it because it has the same scale. Multiply this by 5, multiply this by 5. And the solution, that's right. When the now this is neither here nor there, but when the solution has the same ratio, that means they're the same line. If these are the same, you're still going to have a 0 determinant, but if those are different, then it's going to mean no solution instead of infinite. But that doesn't really matter for what we're doing. Okay, let's look at number 15. Number 15. Dang it. Didn't click the box. Come with me. Alright, to solve these using Cramer's rule, first thing you need to do, rewrite just your system as matrices. I say just your system because you don't really need the xy portion of the 17, 3 right now. All you need is 4, negative 5, 2, 3. What is the determinant of that? $12 minus negative 10, so it's 12 plus 10, so 22. By the way, I didn't mention this earlier. Did you notice that matrix in your DOM looked like it was in absolute values? Like not an actual matrix, but like whenever you see that, in fact, let me go back to that slide for just a second. See how none of these like have a little thing at the top like that cuts in? You know what I'm talking about? Okay, the normal matrix brackets. Whenever it looks like this, that's the book's way of saying, hey, find the determinant. So if you might have a problem on your test with no directions. It'll just be this, and you're going to think, so what do? Try to remember, when it looks like it's in an absolute value, you're finding the determinant. Anyway, back to what I was saying. So the determinant of this matrix was 22. Here is the whole thing about Cramer's rule. Cramer's rule said, now I haven't shown you how to do this just yet, but if you find an x determinant, which I'll show you, and divide it by your overall determinant, that will be what x equals for this system. If you find your y determinant and divide it by your original determinant, that will give you what y equals, and you'll have solved the system. X equals y equals. To find the x and the y determinant, it's actually just as easy. For the x determinant, you're going to take out the x column in your matrix, and you're going to plug in the answers. So instead of the x's, you're going to have 17 and 3, and then your y's are going to stay put. That's the answer column. You just substitute these in for your x's, and then find the determinant. 51 minus 15, or excuse me, minus negative 15, is that 66? So that's dx. It's the exact same as this one, but I took out, for dx, you take out the x column, and you plug in the answers. It's what you need to find this. Well, I'll do that in just a second, but yes. dy, guess which column we're going to take out for dy? That's right, the y column. So the x column is going to stay put, but you're going to take out the y's and plug in the answers. 17, 3. 6 minus 34. Is that negative 28 or something? Thank you. Negative 22. So we're pretty much done. What's my x going to be? It's going to be 66 over 22, 3. And my y is going to be negative 22 over positive 22. And there's your solution. That's Cramer's rule. Because that's how you find the x. You take out the x's and plug in the answers. And then for dy, you do the same thing. Take out the y's of the original and plug in the answers. Yes. What? I use these two formulas, dx over d and dy over d. Oh, the answers came from right here. They're in the problem. What? Where is there a g?
D.
Oh, d. That's your original determinant. Like what you just did. Oh, sure. Well, I just did this right here. dx was 66. D was 22. That reduced to 3, which equals x, dx over d, which is where that came from. Yeah, maybe. Anyway. And then we did the same thing. And then, Jenny, we did the same exact thing with the y's. We took dy, divided it by d, and got negative 1. Yeah, that's right. We're going to do 3 by 3s as well. Questions on this? Let's look at another one. How about... I can. Let me scroll down. You need to see the y. There you go. Notice, before we converted it to matrices, did you see how this equation was already x and y, and then x and y, and then the numbers separated? You will have to, on some of your problems, rearrange that yourself. For instance, everybody got this written down? If your x's and y's are scrambled, or on the wrong side of the equation, you have to rewrite it. X, y equal number. X, y equals number. That way you can pull it straight out into a matrix. We good now? So let's look at number 21. Number 21. So I have to put my x's and y's together and put my numbers separate. So I'm going to subtract the 3y. That gives me 2x minus 3y equals 2. And this one gives me what? 5x plus 4y equals 51. Before I go any further, are there questions about where I got that? Matrix time. 2, negative. Yes, the numbers. 5 and 4. 4. No, don't do this. So, first thing we need is our determinant. So would that be 8 minus negative 15? So 8 plus 15, was that 23? Alright. Now we need dx. Okay, so 23 equals d. These are the 3 things we're going to need. d, dx, and dy. We found d. What's going to be my matrix to find dx? Very good. The answers substitute out for the x's, and you find your determinant. 8 minus negative 153 is, I think, 161. Oh, yeah, but it's minus. Remember, it's AD minus, so it was 8 minus a negative 15. Because it's AD minus and then negative 15. So minus and negative made it a plus. Okay, what's going to be my matrix for my dy? Yes, 2, 5, 251. Determinant, 104 minus 10 is 102 minus 10 is 92. And now all we have to do is dx over d and dy over d. Dx over d is going to give us what? What's 161 over 23, somebody? Thank you. I'm glad you're back. And dy over d, 92 over 23. So my ordered pair is 7, 4, and I'm solved. Questions? No, 161 over 23 was 7. And 92 over 23 was 4. 3 by 3s, which is as high as we're going to go, are the exact same thing. The only difference is, instead of just dx and dy, now we also need a dz. So it's going to be dx over d, dy over d, and dz over d. Literally, other than that, the only thing that makes them different is the way you have to find the determinant. Because you obviously can't just do AD minus BC anymore, because now it's a 3 by 3. There are two ways to find a 3 by 3 determinant, and I'll show you both and let you decide which one you want to do. Click, click. 3 by 3 determinant. I will do number 27 doing the first method. Well, I'll just do 31 doing both methods. Okay. The first method. Take your first row, 1, 1, 1 in this case, and write them with space between them. Okay? Put a minus in front of the middle one and a plus in front of the last one. That's always going to be like that. Now, somebody asked last block, they said, well, what if this number is negative? No big deal, so it'll be minus and negative, but this is going to be one long equation. So regardless of what these numbers are, minus here, plus here. And if they have negatives, you'll apply them as you normally would in an algebra equation. Okay, next to those, here's how it's going to work. The first one was right here. We cross off everything in its row and column, and what's left is what's called its minor, M-I-N-O-R. So that's 2, 4, 2, negative 5. Then we do the same thing with the second one. We cross off everything in its row and column. Oh, wrong direction. And what's left is its minor, 2, negative 3, 2, negative 5. What do you think is going to be the minor of the third one? That's right. Very good. Now from here it's just 3 second order determinants. AD minus BC, negative 10 minus 8 is negative 18. AD minus BC, negative 10 minus a negative 6, so it's negative 10 plus 6 is negative 4, minus a negative 4, plus 8 minus 6. Did I write that right? Thank you. 8 minus negative 6 is 14. So here we go. Negative 18 Was that plus 18? So this one gave you a 0 determinant. And I bet we could have seen that because one of my rows was a complete scalar of the other. That's why that happened. So determinants of 0. Here's the other. Yes, sir. Sure. Absolutely. These came from the 3 numbers on the top, right? So for the first one, you cross off everything in its row and column, and what's left is its minor. 2, 2, 4, negative 5. For the second one, same thing. Cross off everything in its row and column. Its column, because it's the second one. And you're left with 2, 2, negative 3, negative 5. Oh, sugars. Darn it. Well, actually, I think the numbers are going to turn out the same by lucky coincidence. Thank you for pointing that out. Negative 10 minus a negative 6. Fortunately, it didn't change our number. That was a huge slip up, though. Thank you for catching that. So you actually understood. You were just... Yeah, thank you. I guess. Oh, the determinant. These are all determinants. AD minus BC. Negative 10 minus 8. And then that's what you're going to find all the way across. Yes, that's why there was a minus here. That's where that minus came from. Now, I think it's foolish to go ahead and, because some people are like, well, if this is negative, I'll go ahead and multiply. I just like to leave the minus till the last so I don't forget or like overdo it. Somebody last block, they were, like, for instance, we had like a minus, but this number ended up being negative, right? So they're like, oh, I'm just going to make that a plus 2. And then at the end, they kind of freaked out, like, oh, I was supposed to make it a minus. So they like double applied it. So just leave that minus alone until you've done all of this. And then when you're done, do the minus. That's just my words of advice. You don't have to use that. But if you do it too early, you might use it twice by accident. The other method for finding a determinant is this. And most people prefer this method. Write out your matrix, but with no actual brackets around it. Thank you. Then rewrite your first 2 columns again. 1, 2, negative 3, 1, 2, 4. Most people prefer this. Because I wrote my original 3, and then just for this process, you write the first 2 again. Okay? Here we go. Watch this. It's called diagonals. You multiply. 1 times 2 times negative 5 is negative 10. 1 times 2 times negative 3 is negative 6. 1 times 2 times 4 is 8. You're going to add those 3 numbers, but we're not done yet. Yeah. No. Then you're going to subtract, and you're going to do the same thing, but going in the other direction. Negative 6. Positive 8. Negative 10. And you're going to add those 3, but then you're going to subtract those 2 quantities. So that negative 16 plus 8 is negative 8, minus negative 8 again, which gives us 0, which is what we got the last way as well. Again, you multiply along the diagonals, but then you add those numbers together. And then you subtract the sum of the other 3 diagonals. Most people prefer that method. Whatever. I don't really care which one you use, and you do not have to use both today. Just pick one that you like better and run with it. That's how you find a 3 by 3 determinant. Now, where these things can get a tad lengthy are, in just a second, we're going to do a 3 by 3 system, which means we're going to have to do this 4 times for d, dx, dy, and dz. And that's the whole problem, basically, doing those 4 determinants. Yes. Yes. No, you do the first 4. We're not going to go that high, but yeah, you would have to do 4 diagonals. The next 3, yeah. You have to do it 4 times. Alright, let's look at one. Oh, I'm sorry. You can't. Well, if it's not a perfect square, it wouldn't even be a system of equations. The whole purpose of all of this right now there's more uses for matrices, but what we're dealing with matrices is just solving systems. And to solve a system of equations, you kind of need the same number of equations as you have variables, or it doesn't work. Yeah. Mm-hmm. That's right. You'd have layered minors. You know, Sean, I'm about to be straight up honest with you. I've never done that, and I'm going to assume that you know what you're talking about, and that because that sounds right, but I've never done it, so I can't say with certainty. Okay. I've never gone higher than 3i3 with Kramer's rule. This is Kramer's rule, and I've never gone higher than 3 by 3. I just never wanted to. Obviously, I've done a 2 by 2. I'm moving on. Okay, now 37. Let's look at 37. Now, because there are two different methods for solving these, for the determinants. Now, how many do we need? We're going to need d, dx, dy, and dz every time, right? Yes, these are going to get a tad lengthy for that reason. So you need 4 determinants. Now, just for the sake of appeasing everybody, who, if you want to use this way and you want to use that way, I'll do the first 2 using the first method, the last 2 using the last method. Okay. For regular d, that's 1, 1, 1, 1, negative 2, 1, 1, 3, 2. We good so far? That's just the matrix. All I've done is rewrite it. So to find the determinant, I take the top row. What is going on? Okay. So now I need my minors. What's the minor for the first one? Negative 2, 1, 3, 2. What's the minor for the second one? Mucho's good. And the third one? Yes. Wasn't negative. No, wait, what? Why did I make that a 2? Yeah, that's right. 1, negative 2, 1, 3. That's right. Here we go. Negative 4 minus 3 is negative 7. 2 minus 1 is 1. So 3 minus 2 is 1 again. Really? Okay. So that's negative 7 minus 1 plus 1. Oh, this isn't correct. Sorry, I'm going too fast. 3 minus a negative 2 is 5. Addition is my friend. Negative 8 plus 5 is negative 3 for my original D. Question about D. What do you think is going to be the matrix for dx? Exactly. Take out the x column, plug in the answers. I'll do it the same way. 4, negative 1, plus 1. What's the minor for the 4? Oh no. My board's really getting angry with me. He's like, is it the weekend yet? Almost, Moby, almost. What? Yes, he does. Okay. What's the minor for the second? What was his name? Marvin. It was Marvin. Okay. Here we go. Negative 4. Negative 4 minus 3 is negative 7 times 4 is negative 28. Again, that's the determinant times the 4. Minus 14 minus 4 is 10. 21 minus a negative 8 is 29. So, negative 28 plus 29 is 1. 1 plus negative 10 is negative 9. I'll leave that up there for a moment. Are there questions about where any of those numbers came from? I know, aren't they fun? I'm not going to lie to you. There's 4 of these. I'll tell you what. Blah, blah, blah. Here come the excuses. Thank you, Ricky. Man, I've missed you. Maybe we can negotiate when that time comes, but you can't tell first block because I didn't cut their lesson down. Okay, here we go. Oh, dang it, I just recorded this. Okay. Don't tell them anyway. All right, for dy, here we go. 1, 1, 1. Plug in your answers for the y's. Ooh. Then your z column. I don't know what that was. All right, now I'm doing this one by the next method. So rewrite your first 2 columns again. Well, I'd have to do a whole other problem to show, and I'd like to cut people loose after this one, so I'm trying to just... No, I haven't finished it. I did these 2 by this method, I'm going to do the other 2 by the other method, so that everybody can see both methods. Yes, this is a completely different thing. What? Okay. Here we go. 14. I should have changed colors. 14 plus 4 plus 4 minus 7 plus 4 plus 8. So that's 22 minus 19. Is that what you got? Shri? Oh, good. Now we're going to do the same thing for the last one, and then we're done. So that's 1, 1, 1, 1, negative 2, 3, 4, 7, 4. Rewrite the first 2. And diagonals. Change colors, Crawford. Negative 8 plus, what am I doing? 7 plus 12 negative 8 plus 21 plus 4. So that's 19 plus 8 is 11 minus 25 minus 8 is 17, so that's negative 6. We're almost there. Divide them. What's my x going to be? 3. What's my y going to be? Negative 1. And my z? Just 2. Muy bien. We did dx over d to get x, dy over d to get y, and dz over d to get z. Now, I'm going to leave that up there for a moment and pause this. So on to the homework. Just a second, Derek. I'm being recorded. Ixnay on the conversation. Here's your homework. I will not cut it down.